Imagine you're opening a new bank account,
Right?
but you don't walk into this brightly lit, marble-floored lobby.
Yeah, no free coffee or anything.
Exactly. No coffee. You don't sit down at a mahogany desk, and hand over a driver's license to some smiling representative.
Hmm.
Instead, this terminal just slides you a blank piece of paper,
Yeah.
and it demands you physically write down 6 seemingly random dictionary words. Words like, I don't know, blouse and gossip.
Which is such a bizarre visual.
It really is.
Yeah.
And then it unequivocally informs you. It basically says, if you lose this piece of paper, your entire balance is gone forever.
Gone.
Nobody can reset your password. Nobody can verify your identity. Nobody on earth can recover your funds.
It is the ultimate rejection of the safety net we've all kind of grown up with.
Yeah.
Because in traditional digital environments, we've traded our autonomy for convenience. We rely on the institution to act as the ultimate arbiter of truth.
Right, like if I get locked out of my email, I just click a button.
Exactly. If you forget your password, the institution sends you a reset link because, the institution actually holds the keys to the vault. But when you step into the decentralized architecture of Web3,
That custodial relationship is just severed completely,
100% severed.
which is exactly why the transition is so notoriously intimidating for people. And welcome to the deep dive. Today, we have a highly specific, fundamentally vital mission.
We really do.
We are taking a single stack of source material. It's this comprehensive step-by-step text guide, and it's accompanied by a really granular sequence of 15 specific screenshots.
Yeah, 15 of them.
And this material maps out the exact literal process of creating an EOS, or Vaulta account, using a platform called AtomicHub and a piece of software called the Anchor Wallet.
And what makes this specific set of sources so valuable for you, the listener, is that it completely bypasses the theoretical stuff.
Right.
We aren't just sitting here talking about the high-level philosophy of blockchain. We are dissecting the literal entry points.
The actual clicks.
Exactly. The UI decisions, the warning labels, the friction points. The source material basically forces us to look at the exact clicks a user has to make to, cross that threshold from Web 2 into Web 3.
And my promise to you, the listener, is that by the end of this deep dive, that friction is going to make perfect logical sense.
Yeah.
We aren't just going to sit here and read a manual to you. We're going to demystify the mechanisms behind the interface.
Right, because every hoop you jump through has a reason.
Exactly. When the screen tells you to jump through some bizarre hoop, you're going to understand the cryptographic and, honestly, the economic realities forcing that hoop to exist. Okay, let's unpack this.
Let's do it.
Before we even look at the first pixel of the first screenshot, before we analyze wallets or private keys or any of that, we have to address a massive point of confusion.
Oh, yeah. The elephant in the room.
Sitting right at the very top of our source text.
Yeah.
It's the name of the network itself.
Ah, the rebranding anomaly. It's the first hurdle, really, and it's entirely linguistic.
The guide hits us with a major bolded warning right out of the gate. I mean, it says, quote, if you are trying to create an EOS account today, the first thing to know is that EOS is now called Vaulta.
Yeah.
The text explicitly notes that this sudden branding shift just causes absolute panic for newcomers.
Oh, of course it does.
Because if you're following a tutorial, right, and suddenly the logos don't match the URL or the software says EOS but the website says Vaulta, your immediate assumption is, oh no, I'm being scanned.
Right. You think you're on a phishing site.
Exactly.
What's fascinating here is the distinction between branding and infrastructure and, how that plays out in a permissionless environment. Because in the traditional tech world, if a centralized corporation decides to change its name, it happens by executive decree.
Right. The CEO signs a memo.
Exactly. And overnight, every app store listing, every customer service script, every domain name, all the letterhead, it's all updated. The control is just absolute.
They force the update out to everyone simultaneously.
But a public blockchain doesn't have a CEO. The ecosystem is this sprawling, decentralized network of, independent developers, block explorers, wallet providers.
Self-fractured.
Right, decentralized applications. So a core group might vote to rebrand the protocol from EOS to Vaulta, but they cannot physically force the independent team that builds the Anchor wallet to update their interface. They can't force legacy smart contracts to rewrite their code. So you end up with an ecosystem that is structurally sound, but linguistically fractured.
It's like a major nationwide bank undergoing a massive rebrand.
Okay, yeah.
The corporate office changes the signs on the flagship buildings, right? They update the colors on the main website. But your physical debit card, the one sitting in your wallet, it still has the old logo printed on the plastic.
Right.
The account routing numbers you memorized, they haven't changed by a single digit. The actual physical steel vault sitting in the back of the building still operates using the exact same time locks and mechanisms.
Yes, the core is exactly the same.
You can still walk up to an ATM with the old logo, put your card in, and withdraw your cash, even if the receipt prints out with the new name at the top.
That analogy gets right to the heart of the underlying architecture. The source text actually actively tries to de-escalate the user's panic here.
Yeah, it has to.
It essentially tells them, look, do not freak out when you see both names used interchangeably across different decentralized apps.
All right.
Because the underlying experience of creating the account, the cryptography securing it, the mechanics of how the ledger processes your transactions, none of that infrastructure has fundamentally changed just because the community, voted to change the label on the box.
The text literally says, think of it this way. The name may be new, but much of the infrastructure still feels familiar. That is why the smartest approach is to focus less on the label and more on the actual steps you need to complete.
And if we extrapolate on that advice, it speaks to a much broader reality in software development and really network adoption in general. Well, legacy terminology almost always outlives official marketing rebrands simply because developer habits die incredibly hard.
Oh, sure.
You have engineers who have been writing smart contracts and building infrastructure on EOS for half a decade. To them, the variable names in their code say EOS. Their documentation says EOS.
It's baked in.
Exactly. So as a newcomer today, you aren't just learning a system, you are stepping into a bilingual environment where Vaulta and EOS resolve to the exact same cryptographic reality.
Which is such a relatable barrier to entry if you've ever, pivoted into a highly technical field.
Oh, absolutely.
Half the battle isn't understanding the math, it's just deciphering the tribal vocabulary. You sit in on a meeting, people are throwing around acronyms, and you are literally burning mental calories just trying to figure out if they're talking about a database, a competitor, or some new protocol.
It's exhausting.
Yeah, and our source guide is essentially handing the user a translation key on page 1. It's saying, EOS equals Vaulta, take a deep breath, you are in the right place. Now let's move.
And once that linguistic permission is granted, the guide points the user to the literal starting line. The entry gateway.
Let's talk about that gateway, actually.
Yeah.
Because the text is highly specific about where to begin this journey. It recommends navigating to a platform called AtomicHub. Now, historically, if you know this space, AtomicHub was primarily known as a massive digital asset marketplace.
Right. It was where you went to trade NFTs.
Exactly. But the guide points out that AtomicHub has evolved significantly. It is now serving as this streamlined onboarding gateway for the entire EOS or Vaulta ecosystem.
Yeah.
And the text specifically calls out the involvement of an entity called Facings Inc. in refreshing the platform to make it more user-friendly.
And we really need to analyze why an updated, refreshed user interface is so absolutely critical for network survival here.
Okay, yeah.
Because the guide asserts that a clear interface saves time, it reduces mistakes, and makes the whole ecosystem less intimidating.
Which makes sense.
Right. But to understand why that matters so much, you have to look at how people used to interact with blockchains. Early Web3 was just brutal.
Oh, that was awful.
Interacting with a decentralized ledger often meant opening up a command line interface on your computer, typing in raw code, and just, hoping you didn't accidentally send your life savings into a burn address.
It was essentially hostile to anyone who didn't have a background in computer science.
Highly hostile. And even when graphical interfaces started appearing, they were these clunky, developer-focused tools. They assumed the user already understood the intricacies of resource management and cryptographic keys.
Right.
What Facings Inc. and the AtomicHub team have essentially built is a translation layer.
Okay, explain that.
Well, they are taking the raw, unforgiving, complex logic of the blockchain and wrapping it in a clean, recognizable Web 2-style aesthetic.
Ah, I see.
They are using familiar visual cues to guide users through fundamentally unfamiliar architectural concepts.
But even with that clean coat of paint, the guide immediately shatters the illusion that this is just another Web 2 sign-up form.
Definitely what it does.
Before you were even instructed to click a single button on AtomicHub, the text drops a list of strict prerequisites.
Yes.
The first 2 are pretty standard. It says you need a stable internet connection and you need a digital wallet, which we'll dissect in a moment.
Right.
But it's the last 2 prerequisites that really change the atmosphere of the tutorial.
The psychological ones.
Exactly. The guide explicitly states you need enough time to follow the steps carefully, and, quote, extra attention when entering account names or approving permissions.
It is incredibly rare to see a piece of software documentation explicitly demand a user's psychological focus.
Exactly. I mean, tech tutorials usually boast about how fast and thoughtless their onboarding is. Sign up in 30 seconds. One-click registration.
The less you think, the better.
Right. But this guide is telling you to clear your schedule and hyper-focus. It honestly reminds me of the protocol for checking scuba gear before a deep water dive.
Oh, that's a good analogy.
You don't just strap on the air tank, check your phone, and fall backward off the boat.
No, you don't.
You sit on the edge, you meticulously check your oxygen valve, you test the seal on your mask, you breathe through the regulator twice.
Right, because the stakes are real.
Because if you make a careless mistake checking your gear, it's not like making a typo in a Twitter post that you can just delete later. A careless mistake in Web3, like approving the wrong permission or miswriting a seed phrase, it can permanently, irreversibly lock you out of your digital assets.
Yeah.
The ocean doesn't care if you made a mistake, and neither does the blockchain.
That analogy perfectly captures the gravity of a permissionless environment. You know, a blockchain is basically a state machine. It only executes exactly what it is cryptographically instructed to execute.
No exception.
None. It has no context, it has no empathy, and there is no customer support department to reverse the transaction. So the guide is doing the user a massive service by setting this expectation at the absolute beginning. It is effectively saying the training wheels are off, the safety net is gone. You are now operating machinery that requires your undivided attention.
So with our mental scuba gear check, the guide finally transitions us to the visual evidence. We have this highly detailed sequence of 15 screenshots showing the exact onboarding flow.
Let's get into the visuals.
Let's look at the very first interaction on the AtomicHub interface.
Yeah, how does the gateway present itself visually?
Well, the first screenshot is stark. It's really purposeful. It's a dark UI background, and dominating the screen is this bright orange pill-shaped button that reads, Create Wallet.
Hard to miss.
Exactly. And positioned right next to it, much smaller and way less prominent, is a plain text link that just says Login. The visual hierarchy is heavily pushing new users to that orange creation button. When you click it, the interface expands into the second screenshot, presenting a menu of 3 distinct wallet options.
Right, so the user is now being asked to choose their client architecture.
Right. The layout presents 3 separate cards. On the left, inside a blue card with a little tag that says Recommended, is Token Pocket.
Okay.
In the middle, inside a dark navy blue card, is the Anchor Wallet. And on the right, in a bright red card, is Wombat.
3 choices?
Yeah, and the text guide we are following decisively steers the user away from the recommended option on the left and specifically instructs them to choose the middle option, the Anchor Wallet.
And if we look closely at the screenshot for that Anchor Wallet card, there is a list of bullet points explaining its features. It notes that it's free to create, which we need to explore shortly because that's huge. It notes it is compatible with WAX, EOS, and Proton, demonstrating its multi-network capability. But there is a specific bullet point sitting right in the middle of that list that demands our immediate analysis.
User is responsible for wallet security. It's stated plainly right on the card.
This raises a really critical question about the legal and practical realities of self-custody.
How so?
Why is AtomicHub, which is a centralized web platform, placing a liability disclaimer right on the selection button before the user has even downloaded the software?
It is kind of aggressive.
They are doing it to explicitly define the architectural boundary of their system.
But wait, if AtomicHub is providing the interface, aren't they taking on some level of responsibility for the accounts created through their portal?
Absolutely not. And that is the fundamental paradigm shift you have to wrap your head around.
Okay.
When you open a traditional bank account online, the bank's servers generate your account, the bank stores your credentials, and the bank is legally responsible for securing the main database.
Right.
If their database is breached, their insurance covers the loss. But Anchor Wallet is what we call a non-custodial client-side application.
Non-custodial.
Right. AtomicHub does not generate your keys. AtomicHub servers never see your keys. The interface is merely providing you the tools to generate your own cryptographic keys locally on your own machine.
Oh, I see. It's like they are essentially walking me to an empty plot of land. They hand me a pile of bricks, a steel door, and a combination lock, and they say, build your own vault.
Yeah.
But if you write the combination on the wall and someone walks in, do not call us. We don't have the blueprints.
That's the exact structural reality. They are legally and technically washing their hands of your custody because they literally do not possess the architectural capability to recover your assets.
Wow.
It is the core ethos of decentralized finance, just encoded right into a tiny UI bullet point.
So understanding that immense responsibility, you click Select Anchor Wallet.
Mm-hmm.
And here's where the source material presents something highly, highly ironic.
Oh, the next step.
Yes, we are engaging with cutting-edge, decentralized cryptographic technology. We are talking about immutable ledgers and self-custody. And the very next screenshot, step 2 of the process, forces the user to interact with the most universally despised classic Web 2 hurdle in existence.
The centralized gateway check, the CAPTCHA.
Yes. The screenshot clearly shows a standard CAPTCHA verification box.
Right.
Interestingly, in the specific source image provided, the text is localized in Italian. It says, "Non sono un robot," which translates to, "I am not a robot."
Uh-huh.
You have to physically click the little white checkbox to prove your humanity to the server. And I just have to pause and look at the juxtaposition here.
It's pretty funny.
You are about to generate asymmetric cryptographic keys to interact with a global consensus mechanism, and you are stopped at the front door by a pop-up that makes you identify pictures of crosswalks, traffic lights, and school buses.
It feels deeply incongruous. It really does. It feels like a step backward into the centralized web.
Yeah, completely.
But if we connect this to the bigger picture of blockchain economics, it is structurally mandatory.
Mandatory.
Yeah, the text guide explicitly explains the purpose of the CAPTCHA. It is there to block bots and prevent automated abuse during the onboarding flow.
But why is an automated bot such a catastrophic threat to a decentralized network? I mean, if the network is supposed to be permissionless, why do we need a bouncer checking IDs at the door?
Well, to understand the threat, we have to look back at a previous screenshot. Remember the bullet point on the Anchor Wallet card that said free to create?
Right.
We also see a pop-up later that explicitly says one Vaulta account free with AtomicHub.
Yeah, I remember that.
Historically, creating an account on the EOS mainnet was not free. It required an actual financial transaction.
Wait, really?
Yes, you had to lock up or stake a small amount of the network's native cryptocurrency to physically pay for the RAM, the memory storage, that your account data would consume on the decentralized ledger.
So a massive catch-22 for a beginner. You needed to already own crypto in order to create the wallet necessary to hold crypto.
Precisely. It was a massive friction point that just stifled adoption completely.
I can imagine.
What AtomicHub is doing here is acting as a financial sponsor. To onboard users, AtomicHub is dipping into its own treasury and subsidizing the RAM cost for your new account.
Oh.
They are paying the network fee on your behalf. Now imagine a malicious actor writes an automated Python script to interact with this specific free account gateway.
Right.
Without a CAPTCHA, that script could request and generate 10 million accounts in a single hour.
And AtomicHub would be forced to pay the RAM fees for all 10 million fake accounts, instantly draining their treasury.
Exactly. It's called a Sybil attack.
The Sybil attack.
Right, where the attacker floods the system with fake identities to exploit a resource. Not only would it bankrupt AtomicHub's sponsorship fund, but it would also cause massive state bloat on the blockchain itself.
Because it's filling up space.
Exactly, filling the network's expensive RAM with millions of empty, useless accounts. So, while the underlying blockchain is perfectly trustless and decentralized, the web interface offering the financial subsidy must act as a highly centralized bouncer.
That makes a lot of sense now.
They use the CAPTCHA to ensure that only biological humans are claiming these subsidized resources.
Okay, that makes perfect mechanical sense. You click the box, you identify the traffic lights, you prove to the centralized server that your mouse movements have biological imperfection, and the gateway opens.
Gateway opens.
And this is the moment where the process actually leaves the web browser entirely. You are crossing a bridge from the internet onto your local hardware.
Yes, the installation phase. Architecturally, this is a profound transition.
The screenshots map this out meticulously. After passing the CAPTCHA, the web interface displays the message, "Finish your account setup on Anchor Wallet." You are presented with a choice, a button to launch Anchor on this device,
Right.
or a button to download Anchor. Assuming you are a brand new user who doesn't have the software, you hit download.
Right.
The text guide instructs you to install it exactly like any standard desktop application. The following screenshot shows a native operating system prompt again, showing Italian localization in our source, a prior anchorwallet.app. It's your operating system asking for explicit permission. Do you want to allow the website Vaulta.AtomicHub.io to launch this local application on your hard drive.
And this specific prompt represents the handoff.
The handoff.
Right. You are moving from a web application, which is hosted on a server sitting in an Amazon or Google data center somewhere, to a standalone client running entirely within the secure enclave of your own physical machine.
The guide heavily emphasizes the importance of the very next action, too.
It does.
The text reads, quote, "Before anything else, you will need to initialize your wallet and set an access password. This password is important because it protects access to your wallet on that device. Choose something secure, store it safely, and do not rely on memory alone."
Such an important step.
Now, let me challenge this, because this is where newcomers get incredibly lost.
Okay.
This local password I am typing into the Anchor software right now. This is just a password to open the app on my specific laptop, correct? It has absolutely nothing to do with my actual blockchain identity.
You're hitting on the core vulnerability of user comprehension in Web3. You are absolutely correct.
Okay.
Think of the Anchor Wallet application installed on your hard drive as a heavy, physical steel safe sitting in the corner of your home office.
Right.
The local access password you are setting in this step is simply the 4-digit combination to open the heavy steel door of that specific safe.
Okay, I'm with you.
But right now, that safe is completely empty. It doesn't contain any funds. It doesn't contain any blockchain identity.
Oh, because I haven't made one yet.
Right. Later in this process, the software is going to generate your true cryptographic private keys, the master code that actually controls your assets on the decentralized ledger.
Mm-hmm.
Those incredibly sensitive keys will eventually be stored inside the Anchor application, encrypted on your hard drive.
So let me make sure I have this. If I want to send some Vaulta tokens to a friend, I sit down on my laptop, I type in my local access password to unlock the Anchor app. The app opens, accesses the hidden cryptographic keys, and uses them to sign the transaction and broadcast it to the blockchain.
Precisely. The local password protects you from local physical threats.
Got it.
If you are working at a coffee shop, you go to the restroom, and someone physically steals your laptop off the table, they cannot open the Anchor app and drain your funds because they do not know your local access password.
The safe is locked.
Right. The cryptographic keys remain encrypted and safe on the hard drive.
But conversely, if my laptop falls into a lake and is destroyed, I haven't necessarily lost my crypto forever because the true cryptographic keys live on the blockchain.
Ah, careful there.
Wait, no, the keys don't live on the blockchain.
Right, they don't. The public ledger records your balances, but the keys to access those balances only exist where you put them.
Oh, man.
If your laptop falls in a lake, the encrypted file holding your keys is destroyed. If you haven't backed up those keys elsewhere, which we will discuss extensively in Section 6, your assets are permanently unrecoverable, regardless of whether you remember your local Anchor password or not.
Okay, that clarifies the stakes immensely. So we've crossed the bridge, the software is installed locally, we've set the combination for our desktop safe. The RAM feeds have been subsidized by AtomicHub.
Everything is prepped.
Now, the user must choose their identity on the network, and the guide walks us into what I can only describe as a cryptographic identity crisis.
Oh, the naming conventions.
Because the naming conventions on this specific blockchain are incredibly rigid and highly unusual.
Yes, the constraints of the namespace. It is a really fascinating look into database architecture.
We arrive at a screenshot titled Account Creation. The subtext instructs the user to create a EOS account. Below that is a simple text input box where you're supposed to type your desired username. But the text guide hits us with some incredibly strict, almost arbitrary-sounding rules.
Very strict.
It states that the name must follow specific constraints. You are only allowed to use lowercase letters, and you are only allowed to use the numbers 1, 2, 3, 4, and 5.
Absolutely no capital letters, no special characters like underscores or exclamation points.
And notably, the numbers 6, 7, 8, 9, and 0 are strictly forbidden.
Forbidden.
It is so hyper-specific. And looking at the actual screenshot of the interface, there is a text input box, but permanently affixed to the right end of the box, completely outside of the user's control, is a gray block containing the suffix .gnem.
Right.
The text guide explicitly notes, your account will be whatever you choose and end with a .gm.
And if we connect this to the bigger picture of how decentralized ledgers operate, these weird rules start to make profound mechanical sense.
Okay, why?
Why the restriction to lowercase letters, numbers 1 through 5? It comes down to how the core software architecture of the Vaulta or EOS network handles data compression.
Compression.
Yeah, the network uses a system called base-32 encoding.
Let's push that further. What does base-32 encoding actually do, and why does the blockchain care?
Well, a blockchain is essentially a massive, globally distributed database. Every time a transaction occurs, thousands of computers around the world have to update their copy of the ledger.
Right, to keep everything synced.
Exactly. Now, if account names were allowed to be 50 characters long and include emojis and special symbols, it would require significant memory to store and process those names.
They would be bloated.
Very. To achieve massive scalability and high transaction speeds, the original developers engineered the system so that every standard account name must be exactly 12 characters long.
Always 12 characters.
Yes. They then use base-32 encoding to compress those 12 characters down into a tiny, highly efficient 64-bit integer.
Oh, wow. So by restricting the alphabet to a very specific set of 32 characters, lowercase a through z, and numbers 1 through 5, the computer can flawlessly translate the human-readable name into a hyper-compressed string of binary code that the network can process in milliseconds.
Exactly. The strict naming rule isn't an arbitrary UI choice. It is a fundamental reflection of the network's high-speed database architecture.
But what about that permanently affixed .gm suffix? I mean, I can't be just John Smith. I have to be johnsmith.gm.
The source guide actually reveals the meaning behind the suffix. .gm stands for gray mass.
Gray mass.
Gray mass is the development team that built and maintains the Anchor wallet. Remember our discussion about Sybil attacks and AtomicHub paying the RAM fees to sponsor your account creation?
Right, they're covering the entrance fee.
Well, this suffix is the architectural trade-off for that free entrance. In the Vaulta ecosystem, premium custom short names, names shorter than 12 characters, are highly valuable and are often auctioned off by the network. However, the network architecture allows for the creation of sub-accounts.
Okay.
Graymass owns the overarching .gm namespace. By giving you an account under their domain, they are acting as the registrar and the sponsor.
Here's where it gets really interesting to me. It's like applying for a vanity license plate for your car. You get to pick the letters right. You wanted to say fast car. But the Department of Motor Vehicles forces you to include their initials, DMV, permanently stamped at the end of the metal plate.
That's a great way to look at it.
Or, a much more modern analogy, it's exactly like a Web 2 email address. You have total freedom to choose the prefix. You can be coolguy99 or Jando. But you're still fundamentally tethered to the domain provider. You are still at gmail.com or at yahoo.com.
It is a hybrid model. It really blends the absolute self-custody of Web 3 with the centralized onboarding infrastructure of Web 2.
Right.
You hold the cryptographic keys, meaning Graymass cannot touch your funds or freeze your account, but your public identity carries the permanent, immutable badge of the entity that helped you cross the threshold.
Now, inside that same screenshot, positioned right below the text input box where you type your name, there is a distinct button that says Random Name accompanied by a shuffle icon. If you have the opportunity to create a readable name, like david.gm or cryptotrader.gm, why would the UI explicitly offer a button to generate a random, nonsensical string of letters and numbers?
That feature actually taps into the fundamental tension in Web 3 between human readability and financial privacy. We have to remember that a blockchain is a radically transparent public ledger. Every single transaction you ever authorize, every token you receive, every smart contract you interact with it will all be permanently and publicly visible to anyone on Earth who queries your account name on a Block Explorer.
It's like taping your bank statement to the front door of your house.
Precisely. If you choose a highly identifiable name like davidsmith.gom, you are permanently tying your real-world human identity to your entire decentralized financial history.
Anyone who knows your name can see your net worth.
Yes. By clicking the random name button, the system generates a pseudonymous string, something like A4B2C1D35.gm.
It provides a layer of obfuscation.
It creates pseudonymity. It separates your biological identity from your transactional behavior. It basically presents the user with a stark philosophical choice. Do you want a readable identity that is easy to give to friends when they send you funds? Or do you want a private, opaque identity that protects your financial footprint from public surveillance?
So the user weighs those options, enters their desired name conforming to the base-32 rules, and hits Next.
Right.
The subsequent screenshot shows a clear confirmation screen. The header says confirm account creation. It lists the chosen account name. It lists the network, which plainly says EOS. And below that, there is a specific toggle section labeled hardware wallet options.
Okay.
It asks the user if they want to use a Ledger hardware wallet, accompanied by a small graphic of a USB thumb drive. Assuming our user is a beginner without physical hardware devices, they leave this unchecked and hit the large blue Create button.
And at this exact moment, the local anchor software needs permission to execute the action.
Right, the UI throws an authorization required prompt. It forces you to type in that local anchor password we discussed earlier.
You are unlocking the physical safe to allow the software to build the account.
You enter the password, and a loading screen appears with the text work. Verifying account exists approximately 8 seconds from now, and then the payoff.
The best part.
The next screenshot displays a beautiful, clean, uncluttered white screen with large, bold text account successfully created. It informs you that your newly minted .ju account now officially exists on the EOS blockchain.
A massive moment of relief for the user. The friction seems to have paid off.
You would absolutely think so. If this were Web 2, this screen would be the end of the tutorial. You'd continue to dashboard and start buying things.
Done and done.
But the source guide is deadly serious here. The text explicitly states, creating the account is only half the job. The next essential step is to back it up properly. If you skip this part, you risk losing access to your wallet or your account information later. We are now moving into the most crucial, unforgiving phase of this entire deep dive round, the backup process.
The weight of true ownership. This is the moment where the theoretical concept of self-custody becomes a terrifying physical reality.
The visual shift in the screenshots at this point is incredibly dramatic.
How so?
Right below that celebratory account successfully created message, the text reads, "Now let's make sure your account is secured from computer failure by printing an owner key certificate."
Printing.
Yeah. Below that is a bright blue button labeled Create Backup. When you click that button, the interface changes completely. The entire right side of the screen is dominated by a high-quality photograph of a human hand physically holding a piece of paper.
A real photo.
It's a printed document titled Owner Key Certificate featuring a large QR code and blank lines designed for handwriting.
It is a masterclass in UI psychology. Oh, yeah. By placing a visceral, high-resolution image of a physical human hand holding a piece of paper directly into the digital interface, they are trying to aggressively snap the user out of their digital complacency. They are breaking the fourth wall of the software.
The text on the screen reinforces this analog demand too. It says, to be able to recover your account or import it to another device, you'll need the Owner Key Certificate. Let's create it now. You'll ideally need access to a printer and a good pen.
Let's deeply analyze the warning the text guide gives us here, because it is the most important sentence in the entire document.
Okay.
It states, without those 6 recovery words, nobody will be able to recover the private keys. Not the wallet provider, not the platform, and not the blockchain itself.
Wow.
We have to understand that this is not marketing hyperbole. This is cold, mathematical, cryptographic reality.
But wait, I have to push back heavily on this.
Go for it.
We are talking about next-generation digital finance. We just spent 20 minutes dissecting Base32 database encoding, Sybil attacks, and globally distributed consensus networks.
Yeah.
And the official guide literally says, ideally, you'll need access to a printer and a good pen.
I know.
Isn't that totally contradictory? We are utilizing the most advanced digital network on the planet, and to secure it, I am being instructed to use a ballpoint pen and a piece of dead tree.
It feels like an anachronism until you understand the concept of air gapping and the nature of digital threat vectors.
Air gapping.
Right. If your master cryptographic keys exist purely in a digital format, if you save them in a text document on your desktop, if you copy and paste them into your Apple Notes app, if you take a screenshot with your smartphone and leave it in your camera roll, they are fundamentally vulnerable.
Vulnerable to what exactly?
Yeah.
If my laptop has a password, isn't it safe?
Actually, it's worse than that. If your device is connected to the internet, it is exposed to an infinite number of attack vectors.
Really?
Yes. A malicious browser extension could read your clipboard data when you copy the keys. A piece of malware hidden in a downloaded PDF could execute a keylogger to record your keystrokes. A vulnerability in iCloud or Google Drive could expose your synced photos, revealing the screenshot of your keys. A highly sophisticated attacker doesn't need to break into your house to steal your digital files. They can extract them silently across the globe.
So by forcing the user to physically write the keys down on paper with ink, you are doing what?
You are creating an air gap. You are completely removing the most sensitive data in existence from the digital realm. You are translating the cryptographic keys into analog space.
Uh-huh.
A hacker sitting in a basement in another country cannot execute code to extract a physical piece of paper locked inside a fireproof safe in your physical house. The primitive analog nature of the paper backup is precisely what gives it ultimate unbreakable strength against digital attacks.
That is genuinely mind-blowing. The absolute apex of digital technology requires the most primitive physical security to survive.
It really does.
So let's look at how this air-gapped backup actually happens in the UI. You click Continue to Next Step, and the screen shifts. The heading reads Write Encryption Key. The instructions state, write down these 6 words on the certificate you just printed out and keep it safe. Below the text are 6 prominently numbered boxes containing specific words.
This is the generation of the seed phrase, or in Anchor's specific architectural implementation, the encryption keywords.
The source material gives us a clear glimpse into the verification step that immediately follows. The screenshot is titled Verify Your Encryption Key.
Okay.
It instructs the user click to select your encryption keywords to make sure you wrote them down correctly. Below the instructions is a grid of 12 random words. Let me just read the specific options the source image provides because the randomness is fascinating to look at.
Let's hear them.
The words are dish, accident, view, relief, blouse, gossip, tale, angry, palm, ski, 3, inherit.
It reads like a surrealist poem.
Angry, palm, ski, 3, inherit. Completely absurd. I'm securing my financial sovereignty and my digital identity with the word blouse and the word gossip.
To understand why the system uses words like blouse, we have to understand the concept of cryptographic entropy. Right. True cryptographic private keys are essentially massive strings of random alphanumeric characters. They look like absolute gibberish, something like 5KQ, a bunch of random letters and numbers.
Right.
It is mathematically impossible for a human brain to memorize that string, and it is highly likely that a human would make a critical typo if forced to write it down character by character.
Right. You confuse a capital I for a lowercase l, and you lose all your money.
Exactly. So years ago, blockchain developers created a standard called BIP39. It translates that massive, unreadable string of alphanumeric entropy into a sequence of standardized, easily readable dictionary words.
Well, that's smart.
The underlying software takes the raw math of your private key and maps it to a specific list of 2048 common English words. When you write down dish, accident, view, you are actually writing down a human-readable representation of raw cryptographic math.
That is wild.
If you write down those specific words in the exact correct sequence, the Anchor software can mathematically reverse engineer them back into your master cryptographic key.
So you look at your physical piece of paper, you click the correct 6 words in the UI grid. Maybe you sequentially click dish, view, blouse, tail, palm, 3, and you hit continue to prove to the software that you didn't just skip the step.
It forces compliance. It ensures you didn't just take a mental note.
The final screenshot in this grueling backup sequence displays a large, reassuring blue shield icon. The header reads, Key Certificate Security, and subtext below it features a quote that sounds like it was pulled directly out of a high fantasy novel, like Lord of the Rings.
What does it say?
It simply says, keep it secret, keep it safe.
That quote perfectly encapsulates the reality of the paradigm shift. The guide explicitly notes that this printed certificate is the master key. It is the absolute highest level of authority over your account.
Right.
If your hard drive crashes, if your laptop is stolen, or if you simply want to install the Anchor wallet on your mobile phone to access your funds on the go, those 6 words are the only way to import your identity.
No reset button.
No reset button. Storing that paper in a highly secure location, not photographing it, not reading it aloud near a smart speaker, not showing it to a friend, these are the non-negotiable fundamental rules of surviving in Web3.
So you take that piece of paper, you fold it up meticulously, you place it in a fireproof safe, or you lock it in a bank safety deposit box. The analog paper is hidden away from the world.
Safe and sound.
The local software is installed. The account name is registered on the ledger. The process is finally over, right?
Almost. The source guide gives us one final critical instruction. Section 7 of the document mandates a process of trustless verification.
Right, ensuring that everything we just did in the software actually resonated across the decentralized network.
Exactly.
The guide instructs us that after backing up the account, the absolute final step is to verify its existence using a tool called a block explorer. And the text specifically recommends using a block explorer called Vaulta.
We need to define what a block explorer actually is. Architecturally, it is essentially a search engine for the blockchain.
The screenshot we are provided for Vaultasken only shows the top navigation bar of the website. It features a logo on the far left, orange cubes stacked together spelling out scan with a small Vaulta tag next to it.
Okay.
The navigation menu features tabs labeled Home, Producers, RAM and V, Earn 10.26%, and Tools. And dominating the center is a large search bar. In the provided image, someone has typed the specific text EOS support into that search bar.
The guide instructs the user to take the 12-character .gm account name they just created and type it directly into that search bar. When you hit enter, you are doing something profound. You are completely bypassing the Anchor Wallet application. You are bypassing AtomicHub.
Oh.
You are querying the raw public ledger directly to see the immutable state of the network.
It's like a public library catalog combined with an open bank statement. Anyone on Earth can go to the library catalog computer, type in a book name or library card number, and instantly see if the book is checked out, or see what the exact status of the account is.
That's a great analogy.
The ledger is entirely transparent, but only the person physically holding the library card, or in our crypto reality, the person holding the piece of paper with the 6 written words, can actually check the books out or authorize a transfer. Transparency of state combined with absolute cryptographic security of control.
That's the exact mechanism. The guide details precisely what information Vaultasken will return when you search your name. You will see your account creation date, your transaction history, and your available network resources.
The text adds a really specific reassuring note here regarding those resources. It says, some resource values may still appear as 0, which is normal at the beginning.
Yeah.
Why point that out? What resources are they talking about?
Well, in the EOS and Vaulta architecture, an account doesn't just hold tokens. It has to manage network resources to function. Specifically, it uses CPU, which represents processing power, and net, which represents network bandwidth. You acquire these resources by staking tokens. When a brand new user queries their account on Vaultasken and sees a wall of zeros next to CPU and net, their immediate psychological reaction is panic.
Right. They think, did the creation fail? Is the account broken? Did AtomicHub scam me?
Exactly. Nobody likes seeing zeros on a brand new account dashboard.
Definitely not.
But the guide is preempting that panic. A newly minted blockchain account is essentially an empty cryptographic vessel. It exists on the ledger, it is mathematically secure, but it hasn't interacted with any smart contracts yet.
Right.
It hasn't received any external funds. The zeros don't mean it's broken. The zeros prove that it is pristine. The vessel is perfectly formed and ready to be loaded.
So why does looking at this block explorer matter so fundamentally? Why does the guide insist it is the necessary final step? If Anchor says success, why not just believe Anchor?
Because trusting the software violates the core philosophy of Web3, which is don't trust, verify.
Don't trust, verify.
Right. You do not have to blindly trust that AtomicHub's web interface wasn't glitching. You do not have to trust that the local Anchor software didn't freeze and throw a false positive. By querying your name directly on Vaultasken, you are mathematically proving to yourself that the decentralized network of global nodes has permanently recorded your account creation. You are independently verifying reality.
Let's pull back and synthesize this entire journey. Because what started as a seemingly simple tutorial is actually a profound technological gauntlet.
It really is a gauntlet.
We started with the intense confusion of a decentralized rebranding, learning that EOS is Vaulta and Vaulta is EOS, and accepting that underlying infrastructure matters infinitely more than the UI label.
We navigated the gateway through AtomicHub, acknowledging that a clean Web 2-style interface is structurally crucial for onboarding users without overwhelming them with raw code.
We dissected the wallet selection, choosing Anchor, and confronted the immediate legal and architectural reality that we are solely responsible for our own security. AtomicHub washed its hands of our custody before we even clicked download.
We clicked the CAPTCHA, proving our humanity, ironically satisfying a centralized bouncer to prevent automated Sybil attacks from draining the subsidized RAM treasury of a decentralized party.
We crossed the bridge by installing local software, setting a local access password to protect our physical device, while understanding it was entirely separate from our true network identity.
We faced the rigid identity rules, choosing a base32 compliant lowercase name, ending in the sponsored .gmin suffix, weighing the desire for a readable name against the privacy of a random string.
We experienced the profound weight of true self-custody, printing out a physical piece of paper and writing down words like blouse and gossip to permanently air-gap our master cryptographic entropy from digital threat vectors.
And finally, we verified our existence on the immutable ledger using the Vaulta and Block Explorer, trusting nothing but the raw data of the blockchain itself.
It is an intense, demanding process.
Yeah.
But step by step, the friction transforms from an intimidating barrier into a logical sequence of absolute security measures. Now, if you are listening to this and you want to go even deeper into the mechanics of this specific network, the source text actually cites a resource at the very end.
Oh, right.
It mentions a book called Mastering EOS Practical Guide for Beginners and Advanced by Alfredo de Candia. It notes that this book covers all these underlying topics and more, and it's actually available for free on Amazon for Kindle Unlimited subscribers. So the resources are out there if you want to master the vessel you just built.
As we conclude this deep dive, I want to leave you with a final philosophical thought to mull over.
Okay.
If we examine the trajectory of the internet over the last 2 decades, in Web 2, convenience was the ultimate product. We gladly traded our personal data, our digital privacy, and our true asset ownership for frictionless, seamless experiences.
We love the comforting safety net. We outsourced our responsibility.
Exactly. We happily handed over the master keys to massive corporations simply so I wouldn't have to remember our own passwords. But in Web 3, the friction, the analog paper backups, the rigid base32 naming rules, the complex permission structures, the sheer undeniable anxiety of total self-custody, that friction is actually the price of true ownership.
Wow.
It isn't a bug in the software.
Yep.
It is the fundamental feature of the architecture. It prevents censorship, it prevents centralized seizure, and it guarantees sovereignty. So it begs a profound societal question as this technology scales.
What's that?
Are we, as a culture, truly ready to handle the immense, unforgiving responsibility of being our own banks? Or have we grown too accustomed, too permanently comfortable with the safety net of the forgot password button?
That is the ultimate question you have to answer when you pick up that pen and write down those 6 words. Thank you for joining us for this custom deep dive. The world of Web3 is complex, it is unforgiving, but as we've explored today, the underlying mechanics make perfect sense when you understand the why behind the what. Keep your keys secret, keep them safe, and we will catch you on the next deep dive.